All right, well, I'm going to, while people are straggling in, go ahead and do the intros. My name is Karen Reinhardt, and I've been doing this cybersecurity stuff for like 25 years. I deal with PKI, encryption, keys. I do a lot of stuff with keys, and that's where this presentation comes from, is trying to find the way to, one, explain keys, and then the management, and keep everybody from putting their proverbial key under their doormat, which is a problem I see all the time. So, all right. Well, I just went into that. I'm Karen Reinhardt. So I am a principal engineer over at Home Depot. Been there about 3.5 years. Before that, I was with Entrust. Before that, I was in charge of keys and certs for Verifone payment systems. And previous to that, I spent about 9 years with RSA, professional services, living dog years of professional services. And before that, Bank of America and Quest Communications. I was actually a founding security member of Quest Communications back, when did that, around 1999, 2000, of their cybersecurity team. Anyway, I got some contacts up there if you want to write them down. My official Home Depot, LinkedIn. I don't really do X. When they renamed themselves from Twitter, I stopped. And there's a private one I have there, Badger Securities, my own little domain. Anyway, we're here to talk about keys. Keys can be used, cryptographic keys are being all over the place. They're being used all the time. So we're going to talk about some types, the usages, requirements, controls, management, and most importantly, decisions. One size does not fit all. Okay, so I'm going to really grossly oversimplify encryption to start with. So I'm not going to go into cryptography, say, but I'm really going to focus on the keys. So what are the things about keys? Well, first of all, keys are part of a crypto system. And as you'll see by my little formula, which I call my gross oversimplification, but you can see you've got data, and then you've got a key, and then you have a result. The algorithm is the formula being used, and as I said, if you have seen any cryptography and looked at ECC and lattice and all that, you can see why I call that a gross oversimplification. There's two forms of keys, symmetric and asymmetric. Is there one key that's shared, or is there asymmetric, a public-private key pair, or don't go into that. So symmetric, you've got the AES, MD5's not really there anymore. Shared secret, RSA, ECC, and the new post-quantum lattice stuff on that. But something I want to bring up, we talk about data classification all the time, and we tend to define what happens to that data based on the classification, and encryption is always part of that conversation, as well as access controls. But don't forget, keys themselves are data also. And that gets fun when you start talking about what you need to encrypt, and all of a sudden, as we get into usages, we'll talk about identity, because now all of a sudden you could be talking about, but that's being used for how do you, that's being used for this, how do you encrypt it? It's a pre-secret. And you get some weird things going on with identity sometimes. But it is data, and they can exist at rest, stored in a database. They can exist in transit, and they can exist in use. And we'll go through a little bit about how the keys act there and where they go and what kind of controls go into that. But data protection but the one thing you can count on, data protection necessitates controls on keys. You can't just throw the keys into a file on every system and have it work. Well, you can try, but it goes very badly. Okay, so what are cryptographic keys? I'm not going to go through all of this, as I promised, no death by PowerPoint, hopefully. What do they do for data protection? Well, they certainly do confidentiality. That's where we're really used to this, encryption. They encrypt, but they can also authenticate and authorize, which is important for confidentiality, because who has access to your data? You've got to have access controls. So identity goes actually between confidentiality and integrity. What about integrity? Code signing, tamper detection. Secure boot is a wonderful example of a lot of keys coming together to do both encryption and integrity and authentication. And we'll go through some of those examples also. But so you've got encryption, you've got the integrity checking. Availability. I want to point out encryption threatens availability. You've got to be able to decrypt. And I think we've all been in situations where someone lost a password or something else, and now the data is unavailable. By far, and I come from the PKI world, and certainly when you're using PKI for encryption, all of a sudden, if you're using encryption at rest, data at rest, now you have to be able to archive the key somewhere so you can get it back if something happens. So that's the main thing. Think about decryption. Encryption's fine. Data's unusable if you can't decrypt it. So where are your decrypt keys is often a much more important question than where are your encrypt keys, especially in asymmetric. Okay, your public key's out there encrypting things. That's great. Who can decrypt it? And we'll get a little more data there, but just, loss of data. So that is a case where the functional risk often outweighs the security risk. But anyway, I want to dive into types of keys. I put them all together here. So encryption keys, you've got your data encryption key, you've got your key encryption key. Now notice I call that a wrapper because your key encryption key encrypts your DEC most of the time. And I'll get into a little bit because when you do that, I've actually seen KEX being used as identity and being stored in secrets managers, and it's not necessarily a bad thing. So you've got your key encryption key and master key. If you're doing derivatives of keys, if you think them split up, that could be a master key as a definition. And often you've got keys wrapping keys wrapping keys. If you're familiar with HSMs and security worlds, that's a great example of it. Identity, you have authentication keys. API keys, typically symmetric. They can be asymmetric. Client certificate, private key. You have, as I mentioned, the key encryption key. So I don't have a lot of systems. I need to encrypt it. I have a data encryption key. I need to be available on a local system. How do I protect it? Well, I can wrap it. OK, cool. Who can unwrap it? And you can see it kind of becomes a little bit of a logic puzzle. And we'll go into more. Just want to get over the basics right now. Key encryption key often it's going to be asymmetric to wrap it. Doesn't have to be, but that is the common. And often it's to help enforce an access control, because I can control access to the DEC by controlling access to the wrapper. You have digital signature keys. Remember, identity isn't just authentication. It is also integrity and signing. And signing actually says this came from me, this came from somewhere. And depending what you're dealing with, there can be some slight iteration if you're dealing with like Android signing. But it is an affirmation. You do have HMAC or tokens with identity. So you can actually have, keyed and keep a table. And I am seeing this a lot more. I'm seeing symmetric with AES 256 being used with MAC to do authenticated encryption. And we'll get into that. The main reason is it's going to be, it's the one that's most post-quantum proof. So asymmetric is the one that's really is threatened by quantum, post-quantum. And a lot of folks, if you're using AES the right way, it can provide you coverage. And of course, root keys. Again, signing. What do I do with this? I use it, I verify, I sign, I encrypt. Keys are keys. Integrity, you can see again, I brought in the digital signing keys, code signing, tamper evidence, and of course, hashing. And here I'm not talking about just plain hashing, I'm talking about keyed hashing in particular, because other one-way hashes, don't have a key. So those are just some examples. Now, where are the keys? Well, a lot of times they're in a local key store sitting on a system. Other cases, they can be in a remote store. Whether it's a remote key store, an HSM would be a wonderful example of a remote key store. You can have a key management server, a secrets management server. They could be anywhere these days, on-prem, in the cloud, at a vendor, in your own managed cloud. But the main thing to think about is, there's some things there. What are your controls required if you're under mandates? What resources are available? and what solution is the requirement. And as you can see here, this is just a simple thing. It can be anywhere, but something to think about also as you go forward, one thing that's going to come up, talking about key stores, that's going to be kind of limited. What about platforms and stuff? But want to go real quick and just key storage options. I'm not going to go through the whole slide. Mainly, it comes down to key store, key manager, or secrets manager. Want to point out some quick differences. Key stores and key managers deal with just cryptographic keys. Secrets can deal with a cryptographic key used as identity, but it also can deal with passwords and such. Another major difference on your key and your secrets management is you can enforce policy typically with your key management or secrets management, where your key storage, not so much. Key storage, an example of, and I'm not going to get into the details, things like that. If you take something like a GPG key ring, that technically would be like a remote store, but it does start to do some key management. But if you really look at it, it's still not really full featured. But that would be an early example. Okay. So where are they? How are they protected? I go in a little bit. You can see key wrapping, and apologies, that's my picture. As you can see, you've got something, you're just taking a deck, and now you're going to encrypt it with another key, and now you have your wrapped deck, and now you can send that to a database. It's a way of getting at, if you're using something like envelope encryption, you might see something like this, but mostly at rest, local storage. Well, that's something to think about. If you're local, you have a lot of OS. If you're Windows or Apple, you've got an OS key store. Your OS will hold that. If you're Linux, it's going to be much more varied. Android or iOS, of course, have their key stores. Is it in software only? Is it hardware protected anyway? Is there a TPM? Is there a security chip? Is there an HSM involved? And most of the time, network HSM these days. Anything that's doing that, there's something, how secure is this? And that does pull into what your key lifetime is and other risk situations. Remote storage, again, remote key store. It's going to have all the same questions, whether it's remote or not. Is it protected? Is it software? And that's something to think about with your key manager or your secrets management, too. Is it hardware backed? If it's not, how can it be exfiltrated? Now, I'm not saying hardware is the only way to do things. There are some vendors working on some really great software options to provide some real cryptographic strength, but that's not quite there. And most of the mandates for, if you're looking like Gramm-Leach-Bliley, any of the PCI, PCI-Pen, PCI P2PE, all of them want FIPS 140-2 level 3. And that's going to means you have to have an HSM there. So, in transit, session encryption. Diffie-Hellman. That's a great example of encrypting key, using asymmetric to encrypt symmetric keys so that you can deliver them. That's in transit. In use. Now, this is where the secure enclave comes up. Because if you think about it, okay, I have a key, I encrypt something. But where do I encrypt it? Where did I send the data? Do I bring the key back to my local system and then do it, and it's just in memory? Or do I send it up somewhere where there's a secure, where it can be encrypted and they send me back the encrypted, and the keys are used within the security world, for example, or a security domain? I don't want to favor any one vendor. Everything's done up there in a secure enclave. And you've also heard secure enclave being used for like TPMs and security chips. And that is there an environment where I can bring the data inside of the cryptographic envelope and do all the work here so that my key never leaves the secure zone? You gotta look at your use case. Not every use case needs that, but when it is required, such as PCI, it is required. Credit card terminals are a wonderful example of that. Definitely a secure enclave there. Okay, and I talk about end-to-end encryption. End-to-end encryption is actually going to pull all of it together. You've got elements that are encrypted at rest, and they are encrypted if they're in use, and they're encrypted in transit. And I'll get into a little bit about how that gets done and some different options there. As you can see there, also talk about the hierarchy, as you can see all the wrapping and such going on. Physical going to root KMS to KMS to storage. I'll also say you might see, if you're talking about secrets, KMS encrypting secrets. Makes a lot of sense. Okay, some of the best practices. This is probably what you guys are a little bit more used to, HSMs. So risk and compliance, what are the requirements? What's the data classification of what you're trying to protect? Stronger controls almost always equals stronger, more money. Definitely true. So that's what I'm saying. It's not, I'm actually against encrypt everything. It's a lot of money, a lot of processing, extra memory. I'm more of a fan on focus what really needs to be kept secret. And I understand the pros and cons there, and love to go back and forth if you want. Hardware protected keys. Again, you've got different standards. Whether you're using security chips or the other, those are typical. One of the things, as I say, when I say typical, it depends where you are. In a lot of business to business, things aren't encrypted with hardware. But you do need to look, especially going forward, what is the risk? And key lifetime has a major role in the risk presented of the storage. Other thing you might see, this is what's driving the cost up. One, those HSMs are going to be that network HSM is going to be like 30,000 plus each. Now you need 2 of them for DR. Now let's talk about global load balancing. It gets really expensive. You can do as a service. You're still buying the pods. You might save a little money. So right here, split controls, separation of duties. These are all the typical. You need multiple people. How can I really control it? Well, you're still using process and procedure even with all the hardware. So it can get very expensive. Key rotation. I want to point out one, least privilege still rolls. Key rotation reduces the risk of compromise. You can't do it with automation. And there's one of the keys. If you have all your key stores all over the place, everything's manual, you're going to have a higher lifetime. So that's where zero trust is actually right. And if you think about zero trust, one of the major tenets is automation. And we'll get into platform, and you can see how that's actually going to adjust there, because automation is what we're going for in order to keep that lifetime up and make sure all the controls are right. Okay, one thing I want to point out there, key archival for decryption keys. That is if you are doing data at rest. If it's in transit, you don't really have to worry about the decrypt. We'll see that. Okay, layering cryptographic controls. So this is the part that I really wanted to start to get into on that. So identity, encryption. Well, what would authentication be without encryption? Think of your first password store, the original shadow file before it was encrypted. Yeah, that was fun. And well, originally it was only used for practical jokes. But so can you really, but encryption without authentication? It's really kind of a chicken and egg thing, because can I trust my authentication if my credentials were not, kept confidential, if they weren't encrypted? But at the same time, how do I handle encryption and the access to the decryption key if I'm not using identity for access controls? So this is really where identity and data protection really meet. It's at the key level and the cryptographic level. So one thing I want to point out, order of operation is important. Can I trust the user? I don't know. Can I trust the device they're coming from? At the end of it, users are still coming from some sort of interface, and how trustworthy is that interface? And that has a lot to do with assurance. And the little picture I have down here, that's a secure boot showing the chip. And as you see, it's a matter of you have keys burned into the chip or a fuse burned, and there's a lot of variation. Some chips do symmetric, some, like a TPM, can do asymmetric and symmetric. Some support ECC P521 curves. So chips can vary greatly in how they work, but at the end of the day, there's still a hardware root of trust, and they prevent the key from being exfiltrated. Now, symmetric key, that's a question to ask. How do you stop a symmetric key from being exfiltrated? The only way is to use a secure enclave, because there's only one key. So if I look at that, so if I look at that, you can see it's chaining, and that's the boot process to do start secure, and then you'll see it opens everything up. I've got the user environment, now I've got my user key store, and I can now initiate my session. So you can only really stay secure if you start secure. Really kind of simple there. But then that's where, what are you doing with your device? How are you doing the checking? The process and the order is very important on how you set chain of trust. So that's what I'm talking about there, is all the chain of trust, how you do it, and whether or not. Now, you might not need to know for sure. It might not be that important, okay? I'm checking my private email, do I really care? But as you can see with a lot of the attacks, with your phones especially, it's very important that your phone have a security chip now, especially since, if you're like me, everybody's using their phone as a security credential too. It's the what you have. So the what you have is made secure by the chip and the root of control there. Okay, this is kind of an example just to go through. So as you can see in my example here, I have a document, and it has fields, and those fields are getting encrypted with a symmetric key. But then they're being sent across a TLS session to a web server. Now notice, one thing, and this is something that's true of both like a disk or drive encryption, or even a database, transparent drive transparent encryption, TDE, is an example, or TLS. Everything in is encrypted, gets encrypted. Everything out is decrypted. So everything in that session is encrypted, and then once you get to the other side, everything is automatically decrypted. And think about a database too, because this is something I've seen an issue. Just because it's in a database, what that means, and it's encrypted, means that as long as it's in that database, it's secure. But anybody with access into that database it's not encrypted. It's access controlled. So it depends, how do they have access, how can they get that? So it just opens it up, because as soon as if I'm an authorized user, as soon as I go get that data and access it, it is now decrypted. Everything in is encrypted, everything out is decrypted. And that's true whether I'm dealing with a column or anything like that. And I bring that up because this first part here is what I talk about as a payload or field encryption. And if you really want to do end-to-end encryption, that's where you want to do it. It's completely controllable. So if you can encrypt sensitive parts of data, again, data classification, if you can encrypt the data as soon as it goes in, it means it stays encrypted. Yeah, it goes through that TLS. That's nice. I had other data going through there too, and I don't want to give the hackers too much info. But now I don't have to care, is there a load balancer in there? So what? Does the load balancer terminate? Does it pass through? My sensitive data is encrypted. As you can see there, it's still encrypted as it comes out the TLS, goes over to the database, and it's still encrypted inside the database, which is cool, because especially now if you start to look at environments as you're going in, okay, on-prem, which cloud? Was that the cloud we ran? Is that the vendor? Now, if the data ends up in the wrong place where the decrypt key is not available, as long as the algorithm and everything is fine, you're fine. Now, keep in mind, there are people capturing data for when post-quantum comes there, where they can go decrypt it all. So we still need to have a little bit of data hygiene. But in theory, and especially if you're in day-to-day, definitely keeps it more secure. It doesn't matter if it ends up in someone's home drive, you're still PCI compliant. And as you see right here, it goes through, we come out the TLS, and finally, the shipping department, who just needed the address, can now decrypt the address. Now you notice, it's still very delegated, because I did not give shipping the right to decrypt the Social Security. Social Security stayed encrypted. They only took the address. So that's kind of an example of end-to-end encryption. And this is something I actually get all the time. It's just, if you start looking at database encryption and do it at the column level and that, okay, now you've got your keys on each database. Well, how many copies of that database do you have? Well, where are those keys going? Well, how do you update? You get the idea. So that's where you start to get the idea of how am I going to manage all these keys and stuff too. Now, which is where the subject goes on to. So if you look at keys for cloud, cloud started bringing a lot of things. We have our platforms, all of that. Now, then there's one of the things. Okay, I can spin up a platform, and I can have a new platform come up every 4 hours. Well, that local key store is probably not going to work very well. It will be, well, I have seen it. It will be very static. Let's just put it that way. So we have key management servers. We have a secrets management system. And we have a CA, Identity Managed, KMS secrets. So certificate authority is still doing some things with the keys. And a lot of times you have a certificate lifecycle management that can also store private keys also. But it's not the same. I want to point out that a remote repository is not the same as a key management system. Remote repository means I go get your key and bring it back to me. It doesn't mean I'm doing a bunch of cryptographic operations. I'm not keeping track of, oh, what encryption key encrypted this. So if I'm doing key rotation, I need to keep tracking which encryption key was used. And that's the nice thing about a good encryption management system and a lot of key management systems, that they help you keep track of all that, so you don't have to. And same as the secrets management tells you when to change the passwords or whichever. Now, some of the things in looking at cloud and cloud vendors, it becomes important because you have cloud native encryption. AWS, Google, and Azure all have their own encryption and their own key management solutions. Now they offer what's called platform managed keys, and that means the cloud vendor takes care of it for you. It is certainly the easiest, transparent to the user. Example would be at rest. If you're storing out in OneDrive or out in S3, out in a bucket, it's encrypted, at least on the backside. So if someone somehow gets access to that hardware and tries to steal it, well, all that information's encrypted. Okay, but then you have customer managed keys. And that would be like system level, cloud provider. You can use a proprietary cloud management. That'd be like bring your own key. So it's a matter, did I want to use what Google gave me? Do I want to use what Amazon gave me? Do I want to use what Azure gave me? Or do I want to bring my own? One of the things to think about, and the major thing to think about there, is where do you want it to work? If you want it to work in more environments, you can always call the cloud, but that's another thing I can tell you. The automation is built for their tools. So when you're trying to integrate with your own tools, with proprietary tools, with third-party tools, when you need a lot of variation, that's when I've seen having a third-party key management or encryption management or secret can be beneficial because it works with more. And they're making money off of it. It's got to work. And that's what I call enterprise key management. So when I talk about enterprise, that means your entire. So do you have third-party KMS, cloud agnostic? And so think about an enterprise as no longer just your on-prem, it's all the environments you manage. And that's what I mean by enterprise. So that's just a little bit, but mostly comes out platform or customer managed. Now, again, what are some of your decision points? Where does your data need to be available? Now, I want to talk about, real quick, another type of data, not just for encryption, but remember we talked about identity, trust. Trust is a zero, if you think about a PKI boundary, a trust boundary, that's actually one of the original zero trust. Hey, look, it spans perimeters because it was setting up the cryptographic control. So just like I can set up a secure enclave, for identity, it's trust. Where do I trust this? Which do I trust? And that's something to think about also, is you don't need it trusted everywhere. Do you need it trusted across the world? Do you need it trusted across your entire enterprise? Or do you only need it trusted in this one environment? So as we go through and you're looking at, well, do I need an enterprise key management, or do I need just key management for this project? You have to look at where's the data being used. And it's just like with identity credentials, there's places you have to use a local one. What are you taking? But there's, how do you access anything else? But then there's also, where do I have federated identity? Where do I have a full security directory? So all these things go in to the keys too, of where do I want my data to be able to be decrypted? Where do I want this identity to be able to be used and recognized? And all of those are, think of them as cryptographic realms. Some of the other things, so as I said, decryption key availability, that's the main thing. Is the data usable? Integration is the major point also. Where do you need to integrate it? If you're a fairly new company with a greenfield, you might not have the same integration requirements of a company that's been around for 100 years. Cloud HSM support. That is one thing I bring up. Especially if you've got an environment like on-prem and the cloud. The nice thing is a lot of times you can set up an environment where all your HSM are available from no matter where you are. Also as a point, there are different companies that offer shortcuts between the cloud vendors and such, and a lot of them you can actually host some of your HSMs and key management there, so you can actually put it between the hops of the environments too. Like if you've got, you might have a company that you're doing a lot of business with that they do a whole hosted SaaS, and you need to make sure data is good. You might have the environment you do where you're doing a platform as a service, and then of course you've got all your normal stuff. So how do you make that work together? That's where you need to look at the integration and how you're going to make the keys available. Now here's something else to consider when you're, I know at least AWS and Google have external key now, and we'll get into that in a second, but something to think about is whenever you're dealing with a cryptographic system is, can I export the key? Almost every system lets you import it, but can you export it? Because obviously, if you want to centrally manage it, you need to be able to export it from wherever you're centrally managing it, and then you can import it to all your other pieces, and you can get a synchronization going on. So that's where I say you can get like a combined service where you can go for it. Yeah, like right here, Google Cloud, you see they've got external key manager so that you can kick in with another, but it doesn't mean that all the keys are shared backwards and forwards. And that's something to think about is, are you synchronizing keys across environments, or are you going to a particular environment? And it's going to depend on your use case. Okay, I kind of talked about this already of, when is a KEK a secret, when it's wrapping. So I see this all the time. Hey, I've got a client certificate, and I'm using it for this application from this platform, and I'm going to authenticate. I'm going to authenticate here. I need to decrypt something over here, but I'm going to hold this client cert over here, and I'm going to now, when I need it, I'm going to call it over here, and then I'm going to use it this way. So actually, sorry, I'm munging a little bit. Two things. Client certs I see used in secrets all the time, and you think about it, that's just the authentication for a TLS two-way. But I do also see it of, I don't have another way, but I'm required to encrypt this data, and I can't keep my data encryption key right next to the data it's encrypting. By the way, that's a PCI violation, PCI DSS 3.6. Can't have the encryption key right next to the data being encrypted. That makes sense. So one of the things I've seen done is, okay, well, it's got to be there, and I got to have it, so I'll wrap it. And I'm going to put that wrapper in my secrets manager, and now you need to authenticate to get that, so I have applied access controls to my local key store over here. It's, as I said, it's a way to make things work at different times. One of the other major difference too, if it is a decryption key, you need to have backups and archival. The thing about identity is you can always replace it. Okay, you lost your driver's license. Let me get you a new one. But if you have data that's encrypted with something, you can only decrypt it one way. Okay. So I kind of talked about this on the decision points so far. And what are you looking at? So scale. Scale matters a lot. What's the amount of data, amount of transactions, amount of environments, numbers of users? What's the risk? Don't spend all your effort on low-risk stuff. But if it's got high risk, high value, what's a high value asset? What's a high value target? Is it in a place that can easily be gotten to? What industry compliance do you have? Again, where's the data need to be used? There's no reason to put decrypt keys where data doesn't need to be used and is just being stored. Cost versus convenience. I'll get into a little more right there. The architecture pieces, are you dealing with a mesh? Are you dealing with project specific? Do you need a cloud vendor to work? Do you have partners involved? And crypto agility, post-quantum. So one of the things is, and I heard this and it makes a lot of sense, you can't wait to do post-quantum encryption until when the computer is ready. It'll be too late. So that's a matter of getting ready for post-quantum now, and they're looking at like 2026 is where I'm seeing, and I will be confirming, that things are really coming to play. You've got NIST finalizing. There's different HSM vendors and different crypto vendors that are now releasing the post-quantum lattice algorithms, Kyber and such. So it's starting to come into play. So I would expect 2026 to be starting to look at like implementing hybrid PKI or different things so that you could start to get the post-quantum out there and be ready. This is just an example. This is the Google thing, so you can see you have the Google hosted where it's all done with cloud native. And if the key's hosted on Google Cloud, it's more automated, and it's because it's all written in the automation. If the key's hosted out of it, you as the customer have more control, but you're going to have your developers do more writing most likely, or have another vendor involved. So I call this calculated gambling. Who are you? This makes a big difference. So easy one. I've seen some places where they said you can do this all in one place, secrets and key management and stuff. Now, I do know it's not recommended. Even both Google and Amazon, I've read some articles where they're like, look, if you take a Amazon Secrets Manager, it's by default encrypted with the key manager. So again, you have, hey, here's my secrets, but I'm going to tie it back to a chain of control, and I'm doing that cryptographically. But what's your risk of compromise and what's your impact of compromise? If you're a large company, I would say always keep your encryption and your secrets and your digital signing. Make sure they all stay separate. Otherwise, you're waiting to become the next victim. If you think about it, I've worked a number of breaches, of the nation-state breaches, and I can tell you in each case, Active Directory was the target because you get all the keys to the kingdom when you get it. So how easy do you want to make it to get the keys to the kingdom? If you really want to centralize it, you're going to need a lot of extra security. It's easier to make it more modular, unless you can't afford to. If you're at a startup, every major decision is risking your company. Why should this be any different? But you do need to, remember when you're growing as a company, if you're going to succeed, you might need to re-architect some things. And this is a great case. So that's where I talked about your affordability versus risk tolerance. And that's where, right there, if you look at it, the cost of implementing the security controls continues to go up. And you want to look at where the cost of the breach is versus thing and find that intersection. That's your optimum security at minimum cost. Think about how much you're paying for this. Security does you no good if you bankrupt your company. So again, smaller organizations have to make compromises. Larger organizations, this is something when your management is saying, why should I pay for this? You need to come back and take it to the risk, because this is what happens if someone takes advantage of this vulnerability. And then finally, so this is just to talk about it a little bit. So this is just a hybrid multi-cloud, not really end-to-end. And you can see I've got a user coming from the internet. I might be going to SaaS. I might be going to that. I've got going into my platforms. I'm using, in this case, I've got one of the cloud key managers and an external. And if you notice, I have HSM as a service too. If you're using hardware backing in order for your trust and for everything, that HSM is going to have to be available out in the cloud and everywhere. And you need to figure out how you're going to do that, whether you're going to plumb it in. Whereas if you're using that key management service or secret management and you're using hardware backing in the cloud, you do have the option. It's just flipping a switch. Hey, I want the KMS with hardware backing. And you flip that switch, and now you're paying for an HSM also. The cloud vendors have made it very easy to have hardware backing. They do know the reasons for that, but you have an option. And I would say that is something, if you have anything that needs to be medium or higher assurance, definitely choose to get the hardware backing. But that is something to think about. Another thing that I didn't put here to think about, HSMs are sticky. Remember I said, can you export your key? If you can't export your key, that means you're going to have to re-key to change. So something to think about when you're making your decisions in the first place is how long does this need to work? How sticky is it? Because if I'm using the key management service up there and all of that, it's using that HSM. I can't just magically move to a third party and have the HSM magically work. I'm going to end up having to rekey. So that is, thinking of anything else right there. That's the majority of it. As I said, it's really about keys, and I wanted to leave time for thinking. And also, I'll do a plug. If you've got use cases and you want to talk in more detail, we'll have some time now, but I'm also doing a Birds of Feather on the same subject on Thursday. So if you're interested to come talk about your use cases and really, have a more interactive, definitely come to Thursday afternoons, Birds of a Feather. I think it's at the same time. 2000 is where all the Birds of the Feather. So this brings up, so when you're looking at things, one, I want to give you a little homework, and then we're going to open up for questions, and I'll do that. Look at what's going on in your own company. And I bring this up because most companies have quite the breadth. Unless you are able to come up on a greenfield in the cloud, you've got keys everywhere. And you're probably doing it a little better in the cloud. And that is something to think about. Don't undervalue the, as I said, automation and key management as opposed to having it all on local stores. It does have a value. You just need to think about it a little bit more. But as you go, what are you using at your companies? Do you use local key stores? Here's a fun exercise. If you have Linux, everybody, I'm sure a lot of you use Linux platforms. Well, Linux, the key stores are controlled by the application. You could have a Java key store, OpenSSL, could be something else, WebLogic. Look at your local key stores, and here's a question. Has anybody written down where the key stores are mapped to? Do you have any sort of standardization as to where key store locations are? And here's another one for you. Where are the passphrases for all those key stores archived? If they aren't archived somewhere good, that is a big disaster recovery problem. And I also bring this up because of post-quantum. We're going to have to replace every asymmetric key out there. Now you start to see why everyone's like, I like the idea of AES all of a sudden. Post-quantum means every asymmetric key has to be replaced. You need to know where they are. And that is the big advantage of a key management system or any sort of centralized management system now, is it will make finding your keys much easier. It will also make rotating them, but that becomes another thing too to look at. Keep your ear to the ground, look at what's coming out. Talk to your vendors about what they're doing with post-quantum. Are they working with universities? Are they working with these others? Or are they following? You don't need every vendor to be leading, but you want to find out when, you want to know when it's coming and when you need to get started. And the vendors that are more involved are going to have better support for actually doing that key replacement. And also, don't panic. Right now, I can tell you, what are you running your stuff on? If your cloud vendor is not supporting post-quantum yet, and none of your other platforms are, well, it's going to be a very closed system. And you might be able to do it on some encryption, but most of your platforms won't support it. So just need, keeping in mind of when are the platforms going to be supporting post-quantum, that's when you need to start looking at it. As I said, the earliest I think is like 2026 is what I'm starting to see is people starting to really get there. Now with that, I have heard from one vendor, they're already sending some post-quantum capable stuff up on satellites. They can't just bring the satellite down to replace it, so they're sending it up with their best guesstimate. Explore, so look at what your options are. What do you have? Can you use cloud native? Explore your secrets and key management vendors. What are they doing? Another note here, if you're in a larger organization especially, take a look at what might have gotten done open source. Because a lot of times our developers are told to do things and then they're given security requirements and they aren't given the solution, which means they go out and they start looking for one themselves. And I guarantee you, they're most likely going to pick the one with the best documentation, whether the controls are best anyway or whether they completely understood it. So keep in mind as you go, look for open source stuff that might be there. You've got shadow PKI and shadow encryption if you've got large cloud environments, most likely. Developers are going to go have fun. And then I said, just keep your ear to the ground over the next year. FIPS 203 is supposed to be coming out. You've got the module lattice-based encryption right there. You've got vendor PQ adoption that is happening right now, and NIST is finalizing the PQ algorithms. So they are coming here. Little other thing, hybrid versus composite, something to think about. Hybrid encryption is probably going to be the first thing, but hybrid is an OR, RSA or post-quantum, or say Kyber. So it means if one has been compromised, it doesn't matter. It can still be used. There's working on it now called composite encryption, and that is an and, meaning I'd have RSA and this and this. That would mean if you're not sure whether the algorithm is going to stand up, I go ahead and make composite a 3. And as long as one of them wins, we're fine. It doesn't matter if one is compromised, all 3 have to work. So that's one of the things I saw too as it comes on, but how are you going to be able to get that done? That's going to be a question. So I'm going to go ahead and end it there. Come to my session on Thursday, and if there's any questions and answers right now, go ahead and come up to the mic.
So
yeah.
Going back to your encrypt before auth or auth before encrypt, are there any methodologies floating around in this space that are similar to 802.1x, which it's a standard that's used in like wireless authentication, things like that, where you have an anonymous outer session, an anonymous outer identity that's agreed upon, that's allowed to bring up the outer tunnel, and then you exchange your user information, and the only thing that's required is that the client trust the server's certificate, and then you can essentially securely exchange the user information, and if somebody wasn't there at the very beginning, they don't get anything.
And that's something being worth. So in the cloud, there's something auth 0 problem, and that is okay, now I'm going to go to the secrets, and I'm going to get my API. I'm going to use my API key to go to the secrets, and now I'm going to go to the KMS. Well, where'd you get that first thing you were authenticating with?
Yeah.
So is there, some of the protocols kind of deal with it, but the problem again comes from the device or whatever you're coming from. How controlled is that environment as you as you spin it up? Because if I don't have secure boot, it means that I can put something in the middle, and now I can pretend to be you and mimic you and all that stuff. So that's where there's still protocols that do what you're saying, and we can talk about and debate about TLS and whether it actually works now. And believe me, I can have a fun conversation on content delivery certificates. But ultimately, there's not really. I think there's some practices, but I haven't seen a protocol that actually goes into that full end-to-end from the device, because there's so many different devices and decisions, and it all comes down to money. What did you want to buy?
Well, but to that point, that's kind of a discussion. I wrote a presentation for back in 2016, and I introduced this concept of the root of trust, right? Because you talk about the chain of trust, but we haven't really walked towards what I think you're getting at is the root of trust. When could you start trusting that that device was that device? At what point in time? When could you start trusting that that person was that person? When could you trust the identity that they claimed to have had? When do you know they were them? What point does that start from? Because before that point, like if I register for my driver's license and I never registered for anything before that, then you can only count on me being me from the point I registered for my driver's license onward, but not before.
Right. Well, you're also hierarchical. It's a hierarchical trust model. So, and the thing about hierarchical trust, and that is you have to have agreement. So, if I take your driver's license example, yeah, but does the Oklahoma driver's license mean the same as the California driver's license?
Right.
Now, if you look, they made a huge national program. We all had to get special, we all had to get the enhanced IDs in order to travel now, and that would be an example of someone has to step in and set that. Now, as you look at things, I would say, think about management versus governance also, because we have such a wide variety of things now that will hierarchical work well, or do I need something that's more of a delegated trust model, and then how does that work together? I don't have all the answers, but I could say if you get too hierarchical, it seems to become unworkable. But at the same time, if you don't have, and that's one of the things on the standards, if you don't have standards that everybody agree to, it's not going to work either. And as I said, I think earlier, I brought up federated identity. That's where it starts to look finally kind of similar to that, and I think people here have seen how well everybody's done on federated identity. It's going to be similar problems.
Yeah.
And also, I do know that there is some vendor assurance, so different devices like phones and things like that, there are different vendors that will actually say this one's more trustworthy than the other. And there are third parties that sell that to different companies. So I've seen that's kind of how it's gotten done. So, all right.
Thank you.
I want to thank everybody for coming. As I said, if you want to be more nerd-tastic and geek out on keys, come Thursday to the Birds of Feather. Thank you very much.